Okay, we're going to look at two methods to factor quadratics that are given in standard form when the a value is not equal to 1. So the a value is the coefficient for x squared, and here we can see that it's equal to 4. So in both of the methods, you're going to not look for a product of 12, but you're going to take the a value times the c value, and you get a new value of, in this case, 48. Now this is the number that we're going to look for two numbers that multiply together and give me 48 and add together and give me negative 19. So I could think of 1 times 48, 2 times 24, 3 times 16. Now it's important to remember if this sign's positive, then both signs in my factor must be the same. And this is negative, meaning that both of them should be negative. So I actually have my factor right here if I consider this a negative 3 and a negative 16. Those are going to multiply together and give me a positive 48, add together and give me a negative 19. So let's look at method 1 once we've figured out these numbers. The first method is called splitting the middle term. And what that means is we're going to split this term into two separate values. So I can think of this as 4x squared, and then instead of negative 19x, since I know negative 3 and negative 16 add up to that, I'll take negative 3x, and then I'll take minus 16x. So I've really split the middle term here, and then I'll finish with a plus 12. The only thing I've done is rewrite this term. Now, what I'm going to do is I'm going to take a common factor out of both of these parts, and the only common factor I see here is an x. So what's left on the inside is just 4x minus 3. And then I'm going to look for a common factor here. And it looks like 4 goes into both of these evenly, but I'm going to take the sign from this first one as well. And you'll see why in a second. So I'm going to subtract 4, and that leaves on the inside here just a 4x, and that makes this minus 3. Now, if you've done this right, what you should notice is that this term here, that binomial, is the same as this binomial there. So what I'm really going to do is I'm going to factor that out, and it becomes 4x minus 3 times the quantity x minus 4. And that's kind of the trick of this method, is you have to factor out a binomial, which is probably one of the first times you've seen that. But obviously, if I took this x and multiplied by both of these terms, that's equivalent to this first expression. And if I take the negative 4 and multiply by both of those terms, it's equivalent to that expression there. Now, the second method we're going to look at is very similar to this. You're going to start the same way, and you're going to do the same list of numbers, except for when you get those numbers, you're just going to organize it a little differently. And I've heard this called the box method before. And you'll see all I'm really doing is organizing what we have in our other method. So we're going to keep our 4x squared, and we're going to keep our 12. But then I'm going to split the terms once again. So maybe I'll take my minus 3x here, and I'll take my minus 16x here. And when I go to find the factors, I'm going to do the same thing. So looking down this column, I look to see what's the common factor. And the common factor here is x. And then looking down this column, the common factor between negative 16 and 12 is 4. But once again, I'm going to take the sign of the first one. So this is going to be x minus 4. Then I look over here to see what's the common factor. And actually, this one shares 4 as well and an x. So this is going to be 4x. And then this one's going to share a 3, and once again, I have to take the sign of the first one, so it's minus 3. So I can think of this as 4x minus 3 times the quantity x minus 4. Okay, now we're going to look at an example that's a little more complicated. So I'm going to multiply my a times my c term, and then I get negative 120, which is a large number to try to look for the factors. Once again, rather than trying to look for numbers that add up to 7, it's much easier to find numbers that multiply to give me negative 120. So I have 1 times 120, and then I can keep going. 2 times 60, 3 times 40, 4 times 30, 5 times 24. And the whole time, I'm trying to look and see, do these numbers add, or in this case subtract, since one of them will be negative, and give me 7. And this one, 20 minus 6 gives me a difference of 14, so I'm getting closer. 7 doesn't work, and 8 goes into 120 15 times. Now it's at this point that I realize 15 minus 8 is 7, so I know that I'm done. Since the 7's positive, this needs to be positive, and this needs to be negative. So let's see what this looks like. Let's do the box method first for this one. So if I draw out my box here, and I put in the terms that I already know, the a term with the x squared stays the same, and so does the c term. But then I'm going to split this middle term, and I'm going to put a negative 8x here, and I'm going to put a positive 15x here. And then when breaking this up, once again, I'm going to look at this column and see what are the common factors. My common factors are going to be 2x, and since this is positive, this stays positive. Common factors here would just be a 5, because a 5 will go into 15 and a 5 goes into 20, so it's a plus 5. And then what I'll have to do is look at this other one. So common factor here, 3 goes into 6 and 15, and x goes into x squared, so this is going to give me 3x. And then I have a negative 8x and a negative 20, so the largest number that goes into both of those evenly is negative 4. So my factors are going to be 2x plus 5 from the top, and 3x minus 4 from the bottom. Now if I did this with splitting the middle term, I would have done this, 6x squared, and I'm going to keep these same terms. So notice you have to do that either method. I'll say minus 8x plus 15x, because that cancels out and gives me 7x, and then the minus 20 stays the same, just like the 6x squared stayed the same. Now I look for common factors, and the common factor with 6x squared and negative 8x is actually just going to be 2x. What's left over on the inside is 3x minus 4. Over here, I'm going to take the sign of this one, so it's going to be plus 5. And then what's left is 3x minus 4. And I notice once again, this binomial is the same as this binomial here. So what I can do is actually just factor out that binomial. So I'm going to have 3x minus 4 times the quantity 2x plus 5, which is the same answer we had before, just with a different method. Now, if you're just watching this video to get a basic understanding, you're to the point where you can factor quadratic equations in standard form. But if you want to see something a little more advanced, or if you want to see something else that can happen, I want to show another example of something weird that happens. So imagine I have 2x squared minus 4x minus 16. And so I'm going to say, okay, 2 times negative 16, we know the drill, equals negative 32. Okay, so that's 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, and then I see, okay, here's my difference. This is negative, which means the larger one must be negative. So I have the two terms that I'm going to use. And if I set up my box for the box method, what's going to happen is I write in my 2x squared and my minus 16. And then I write in the extra terms that I have. And so I'm going to say minus 8x and plus 4x. Obviously, adding these two together gives me that negative 4x there. Take out my common factor. Here it's going to be 2x. Here it's going to be minus 8. Here it's going to be, well, 2x again. And then here it's going to be 4. So I'm left with 2x minus 8 times 2x plus 4. And you might be thinking, oh, great, we're done. But if you look here, and we just checked even just this first term, 2x times 2x gives me a 4x squared, which is clearly not the same as this. And the reason this happened is because our original problem actually had some hidden factors in it. Each one of these terms is even, which means I could have factored out a 2 from the very beginning, and then I would have made this into a much more simple problem. At this point, I can just keep that 2 out here and then factor the inside like normal. In other words, if a is equal to 1, I'm just looking for two numbers that multiply together to give me negative 8 and add together to give me negative 2. So I'm going to have x. Since this is negative, I know that one sign's positive, one sign's negative. Look at all the factors of 8. 1 times 8, those don't subtract to give me 2. 2 times 4, it looks like that's going to be it. Since the negative 2x, or since 2x is negative, then this one must be negative, so that my answer will end up negative. And there you have it. So if there's a common factor, factor that out first, and then it might just be an easier trinomial to factor, or you might have to go through a similar process, but this time it'll work out because you won't have that common factor in it.